Thank you. So this is a very introductory talk to Python packaging. The goal is just to tell people how to get started with Python packaging and clear up a lot of information that you are bombarded with when you try to get started, because Python packaging historically has always been kind of a mess, and things are changing now, and I think we are going to a better place. But in the meanwhile, there's a lot of old information that's kind of outdated and that you will find on the internet. People saying, "Oh, you should do this, you should do that," but a lot of that information is outdated. So I just wanted to explain a couple of things and how things work, so that if you want to get started with Python packaging, you should be able to do that a little bit easier. Okay. So about me, so, I've been involved in Python packaging for around 3 years, and before that I was involved in Linux distribution packaging, and it has been for 5 years. And I'm also an upstream maintainer for PyPI build, which is a package called build, just build, that you will install using pip install build, and it's on the PyPI umbrella, which is the Python packaging authority. And then I'm also upstream maintainer for Python. I've been mainly working on the sysconfig module and the import system, the import machinery. And lastly, I'm a packager for Arch Linux. I've been mostly focused on Python tooling and hardware development stuff, like cross compilers and FPGA stuff and stuff like that. But yeah, so before we talk about Python packaging, it probably makes sense to understand what packaging is in general, which essentially it just is a way to share code within people. So let's say if I write some code and now I want to share it with you for you to use, I have to do that somehow. And the way that I do that is by bundling it into something that I can easily share, which is what we usually call a package. I don't know if that was there the whole time. No, okay, that's good. But yeah, so like I was saying, we have some code. You want to share it with someone. You essentially bundle it in some way, and then you give that to them, and then hopefully they will be able to take it and do whatever they need to do with it. So what is required for this? Well, generally the main thing really is a standardized format. This usually is some sort of compressed file, like a zip or tarball. It doesn't have to be compressed, but usually it's just some kind of bundle format. And in fact, Python, the format that we use in Python packaging is technically a wheel. It's called a wheel. It's technically a zip file, with just some more information on that. But yeah, so this distribution format will usually, like I said, usually consist of a single file, because it's just easier to share, and then it will contain your code, and then usually also some metadata, like the name of the package that you are sharing, and the version, and maybe the dependencies and some other information. And additionally, you might want to have some other components to make it easier. And I think the key main thing is a package repository, so that you can then take your package, put it in a repository, and then anyone that is looking for your package can just go there and download it and then use it, instead of having to get it from you, or from the GitHub page for your project or something like that. So what does this look like in Python? Well, we essentially have two distribution formats. The main one is the binary one, which is called the wheel. And then we also have the source distribution format, which we call slist. And usually it has a targz file. It doesn't have to be a targz. It might use a different compression, but yeah, don't do that. If you're hard, don't do that. Almost everyone uses targz. This is kind of an issue because this is one of the sort of things that were never really standardized properly. People just started doing it, and now we are here. And then we have the package repository for Python. We use a repository called PyPI, which stands for Python Packaging Index, and it's spelled PyPI, not PyPy. PyPy is actually a different project. But yeah. Okay, so you might tell me, okay, but I don't know how any of this work. I don't really want to understand like how does the format that we use work or anything like that. I just want to ship my project to users and have them use it and do it in most simple way, the easiest way, so that I can just focus my time on writing my project and working on it and improving. So you don't need to. We have in the Python ecosystem, we have something called build backends. And the goal of build backends is just to implement the package generation for you. So you give it your code, metadata, and maybe some more settings or more configuration information, and then it will generate the actual distribution files. So usually, like I said, you give your source code to the build backend, then build backend will return you a file. Then you will usually then upload that file to the PyPI, which is the package repository, and then a user that just wants to get just wants to use your project, just goes to PyPI and asks, I want the project with this name, and then just PyPI will return the file. Then they can just install it and just use it locally. So before I talk about modern Python packaging, it makes sense to talk a little bit about the way that things used to be done before, because this is one of the things that I always mentioned, that you will see a lot of information online, and maybe a lot some people here have also used this and are confused by what is happening right now. But yeah, so you have probably seen a setup.py file. As anyone here has written or used the setup.py file? Okay, not many people, but yeah. So this used to be the way that you package Python projects. And now I shall give a little bit of background. So it is a very, very simplified history. Actually, between the first 3 points, I think it's probably over like a decade, and lots of things happen. But yeah, so the way that Python, the way that packaging things in Python got started was mainly with the addition of this utils module to the Python standard library. And this provided a way to just install a project on your system. But this has had many issues, like it was slow to update because it was tied to the standard library. So the only way to update it if there was a bug or something like that, the only way that you could update it was to actually update your Python version. And then, as you probably know, that's quite tricky. And this couldn't support all possible use cases. And because of that, over time, a lot of different alternatives started showing up. And then eventually setup tools as emerged as the kind of the de facto choice. Like everyone is using it. And then this got kind of solidified with the when pip was created. Because before that, there wasn't really any like package manager in Python. So Python packaging actually got started a long time before Python, before packaging managers started showing up in Python. So that is something that we have to kind of play with and have to build on top of. So it's very difficult. But what we have done now is we have started standardizing an interface for build backends. This means that everyone can write their own build backend. You are not forced to use setup tools. So you should be able to just to write build backends that are specific for a certain use case and have that work really well on that use case. While setup tools will never be able to do that because it has to support everything, but it can never support everything properly as you probably would like to. So you will always run into issues kind of, okay, setup tools supports this sort of, but not that well, and you run into weird issues and stuff like that. So the idea is to make it possible to have interchangeable build backends. So instead of using setup tools, I can use something else. And with this standardization, it made it so that writing new build new packaging tools and package managers, it made it possible to actually write alternatives to pip or other different packaging tools, because now you are not tied to the way that pip does things, because we have a standard, and then you can just look at the standard. You see, oh, this is how this thing works, and I know that it works this way, and then you can be safe about what you are doing. So this is kind of the double-edged sword of creating a standard and letting everyone write their own build backend, is that now that if you want to get started with Python packaging, there are like 30 different options. And I have some of them here. So for example, you can still use setup tools. It's a very good general purpose build backend. It will work on most situations, but there are also other alternatives like Fleet, Arch, Poetry, PDM. And there are, like I mentioned, some alternatives that are specific for certain use cases. For example, metering, which is very good for Rust. So if you want to write a Python package in Rust, you probably want to use metering instead of trying to use setup tools or other backend to compile your Rust code and then build you a native Python extension and all that. It can become quite difficult. So metering makes that really easy by integrating directly with Cargo, and just makes it super makes it a super nice user experience for a problem that's very complex. And then there's also some other build backends like Meson Python and Scikit build, which allow you to use a different build system like Meson or CMake to build your own native extensions and just then they will act like a bridge. They will invoke either Meson or CMake and then generate a Python package from it. I think if you want some guidance, because it's a very complex thing, I think the best resource that I've found so far is the PyOpenSci packaging guide. So Leo Weber, who works on PyOpenSci, made this really nice diagram that shows when you might want to use each build backend, and it makes it very easy to allow you to get started into packaging without having to think too much, or maybe choosing one backend and then down the road you see, okay, but this actually doesn't work very well for this specific thing that I need to do. So now I have to move to a different thing. So yeah, this would be my recommendation. If you need some guidance, you can also talk with people. I will avoid, like I said before, just Googling stuff. Because or if you are Googling stuff, please keep in mind and look at the dates at when that was posted, because things are changing very rapidly, and now and a lot of tools are showing up right now that will be maybe better suitable for your use case. So now for actually creating a project, I think that the first thing that you want to do is looking at the documentation for the build backend that you choose, and they will generally have some decent documentation about how to get started and how to create a new package. But this usually just the first step for all backends should be to create a PyProject.toml file in the root of your project, and then adding this build system table there, where you specify the build requirements that you have, so the packages that are required to build your project, and then the actual build backend that you want to use. And this the string that you put there will be documented on the documentation of your build backend. In this case, I'm using HLink, which is the build backend used by H. And then you will want to add the project metadata, stuff like the project name, version, description, authors, all that sort of things, the dependencies that your project might have. And there is a standard way to do that in PyProject.toml, but it's not supported by all backends. So you want to look at the documentation for your build backend to know if this is supported or not. But most, I think, actually, all of the build backends that I've mentioned before support this. It will look something like this. You have a project table, name, version, description, requires Python, which is the minimum Python version. I mean, not necessarily the minimum Python version, but you can specify the minimum Python version there. License, and there are other fields that you can add that I have not listed here. You can find them at the declaring project metadata page in the PyPA specifications. Yeah. So after you have done that and you have your project, you want to build your package, and then you probably want to upload it to PyPI. And the way that you build your package, a generic way is to use the PyPI build tool, which after installing, you just run python-m build, and then it will create the source distribution and the wheel file, which is the binary distribution, on this folder. And then after that, you can upload that you can share those files with people, and you can upload them to PyPI. And one way to do that is to use Twine, where just do Twine upload and then the files. If this is the first time that you are doing this, it might make sense to upload it to the test PyPI first, which is a test instance of PyPI, which is not permanent. So you can upload it. You can upload your package there, make sure that it shows up, and then afterwards it will after a little while it will disappear. I should also note that some build backends like Fleet, Arch, and Poetry also have their own CLI where you can do these tasks, or even more, which is nice for the development experience. For example, yesterday someone talked about using Poetry, how that kind of helps, and this is something that you might also consider when you are choosing a build backend. So now I want to just have very small demo here. So for example, I have this project, which this is the data that I used in the presentation. Then I have my project.py file, which just has a simple function, and I have a license here, doesn't really matter. And then if I go to my terminal and then I run this, oh, okay, so that's happening. Murphy's Law. Okay, let's just try again. Interesting. Okay. I don't know what's going on. But yeah, so so yeah, if you run these two comments, you should be able to get and this is the simplest example that I've used in a presentation. Somehow it still managed to screw up. Yeah. But yeah, so does anyone have any questions? If you want, the slides are on my GitHub. And if you have questions about packaging or want to talk about packaging, feel free to find me afterwards. I'll be happy to talk about that. I've been working on it for a while, and I've seen a lot of weird scenarios on that, so maybe I can help you, or yeah. So doesn't anyone have questions?